All right. Hello, everybody. Today we will be working on solving systems with graphing. So I'm going to share my screen with you and get going. So remember that a system of equations is really just a problem that has two equations. So our first problem, as an example, is 4x plus y equals -1. And our second equation as part of our system will be y equals x plus 4. Now, since we're solving this system by graphing, what we're trying to find out is where do the graphs cross? That's the whole goal in terms of solving by graphing, is figuring out where do the two equations cross. A real deficiency with this method is unless you've graphed something perfectly, meaning your tick marks are perfect, your angles are perfect, your plots are perfect. This is really just an estimate, right? But we're thinking about the relationship between the two equations graphically. So we want to know where do the graphs cross, and we need to recognize that this is limited and is generally speaking just an estimate. So I'm going to graph the first equation showing my work in red. And I'm going to use the intercept method of graphing just as a reminder, since that top equation is in standard form. I'm going to let x be 0. And when x is 0, y is -1. I'm going to let y be 0. When y is 0, x is -1/4. So when I go to graph that, I'm just going to graph the two intercepts. And you could have chosen to do a lot of different things there with that particular graph. I just happen to choose the intercept method in that case. So I'll plot 0, -1, -1/4, 0. And here is a rough sense where my line is. And we can already tell that this is not perfect. That's not perfectly straight. I'm sure -1/4 isn't in the exact right place. So it just kind of highlights a limitation of this method. The second equation is y equals x plus 4. It has a y-intercept at 4 and a slope of 1. So I need to go up 1 and to the right 1, or down 1 and to the left 1. And I can see that based on my graph, even though it's not perfect, it sure looks like the lines cross at that point. So I would say my answer is the point 1, 1,3. So that's the first problem. I'm going to do two more examples, and then 2 examples of odd situations that happen if you're using the graphing method. Second problem, the first equation, which I'll just write down in red, is y equals 6x plus 3. The second equation, which I'll write down in blue, is y equals 2 times x minus 1 plus 5. So I just need to graph these, and it's pretty nice that these two equations are in forms that I know. The first one is in slope-intercept form. The second one is in point-slope form. Graph the first one in red. It is a line with a slope of, or y-intercept of 3 and a slope of 6. So I need to go up 6 and to the right 1. It's going to be up here. Give myself enough space. I need to go down 6 to the left 1. And this line looks something like that. My second line is in point slope form. I'm going to graph that in blue. So I'll plot the point 1, 5. 1, 2, 3, 4, 5 here. And the slope is 2. So I'll go down 2 and to the left 1. And these worked out nicely because they happen to have the same y-intercept. They landed in the same place. So I would say my solution based on where they cross is the point 0, 3. Third example, where things just work out probably nicely rather than having a strange outcome. My first equation, which I'll have in red, is 0 equals 4 plus y plus 3x. That's not in any form, so I'm going to have to adjust, make some decisions about what I want to do. My second equation is y minus 1 equals 2x, also not in any form, so I'm going to have to do some work to manipulate it. This first equation, I'm just going to put it in slope-intercept form by subtracting 4 from both sides and subtracting 3x from both sides. When I do that, the equation is negative 4 minus 3x equals y. My second equation, I'm just going to add 1 to both sides to also put it in slope-intercept form and get y equals 2x plus 1. So I decided to put them both in slope-intercept form. I could have used the intercept method to graph there. Could have put it in standard form and used the intercept method. Process-wise, it's not super important as far as you use a valid process. The first line, which is in red, has a y-intercept of negative 4 and a slope of negative 3. So I'm going to go up 3 and to the left 1. That line looks something like this. The second equation has a y-intercept of 1 and a slope of 2. So I'll go up 2 and right 1. That line looks something like this. Obviously a sloppy line. These 2 points intersect here. The way my graph looked, it wasn't exactly on the x-axis, so I'm going to estimate this point. To me, this looks to be about negative 3/2, comma 1/4. I'm confident that's not the right answer, but again, remember that the graphing method is really just a method for estimating. So there's 3 problems that worked out nicely. Notice on the third problem there, we didn't have to have equations in any given form. We can always adjust them to what we know. All right, 2 more example problems. These are going to be situations that turn out strange, where we have a strange outcome, and so we need to know how to deal with that. In the fourth example, the first problem, the equation in red will be negative 4y plus 4 equals negative 2x. The second equation, which I will write in blue, is 4 equals negative 3x plus 4y. The first equation, I'm just going to put this into slope-intercept form. I'm going to solve this first equation in red for y. I will subtract 4 from both sides and then divide by negative 4 to get y equals positive 1/2 x plus 1. My second equation in blue, it's in standard form, so I'm just going to use the intercept method to graph it. Could have done anything, chose to do that instead. So if x is 0, then y would be 1. If y was 0, then x would be negative 4/3. Okay. So now I'll go to graph these. And this is a situation where something works out strange. So this first line, the nope, nothing works out strange here because I wrote the original problems down wrong. So let me erase these and we'll start again. I have the option of pausing this. Just have to deal with my mistakes. All right, sorry about that. Let's try again. First equation is negative 4y plus 4 equals negative 3x. Second equation, which I'll actually put in blue, is 4 equals negative 3x plus 4y. Starting with the equation in blue, I'm going to use the intercept method to graph this. If x is 0, y would be 1. If y is 0, x would be negative 4/3. With the second equation, I'm actually going to use the intercept method for it as well. I'm going to do my work in blue or in red. If x is 0, then that will give me negative 4y plus 4 equals 0. Subtracting 4 from both sides, I will find that y equals 1. So these equations have the same y-intercept. If I set x to be 0, if I set y to be 0, I will get 4 equals negative 3x. So x equals negative 4/3, which means that these two lines have the exact same x and y intercepts. Now, if I had chosen a different method of graphing, I might not realize they have that much in common. But what will happen, no matter what method you choose, is if we were to go to graph this, here's the y-intercept, here's the x-intercept, the two lines would be right on top of each other. They have the same slope and the same y-intercept. Again, this is a situation where you have the same slope and the same y-intercept. In that case, the lines are the same, and we would say there are infinite solutions. And recall, this is because the lines are coincident. They coincide. They're on top of one another. All right, one example left. Do it off here to the right. In this problem, another unique situation, we have an equation. It's 2y equals negative 2 minus x. Second equation, I'll write it in blue. It is, let's say, negative 3 plus 2x equals negative 4y. I'm going to put these both in slope-intercept form. In the first equation, if I just divide by 2, I get y equals negative 1 minus 1/2 x. In the second equation, if I divide both sides by 4, I get 3/4 minus 1/2 x equals y. Now notice that these two equations that are in slope-intercept form have the same slope and different y-intercepts. So that tells me that I already know that these two lines are parallel. They have the same slope and different y-intercepts. So if I were to graph the first one in red, it has a y-intercept of negative 1, a slope of negative 1/2. So if I go up 1 and to the right 2, this line will look something like that. Second equation in blue has the same slope but a different y-intercept. Its y-intercept is 3/4. If I go up 1 and to the right 2, these two lines are parallel, which means they will never cross, which means there is no solution. There are no x and y values that make this equation true. That should be a full review of the entire set of issues for graphing equations. So I hope this helps.